General Atomics Aeronautical Systems, GAASI, has released images of a brand new, fully constructed advanced air combat drone called the XQ-67A. The company built it as part of a contract to support the U.S. Air Force's Secretive Offboard Sensing Station, OBSS, program. Though an explicit connection has not been made, there have been indications in the past that this design leverages work the company is doing on Gambit, a novel family of advanced drones that involves different airframes that can be mated to a modular common core chassis. The pictures of the XQ-67, as shown in this story, were taken at an undisclosed location. General Atomics, as well as Kratos, first received the contract under the OBS program back in October 2021. The Air Force subsequently chose General Atomics alone to proceed to actually build and flight test its design. General Atomics Aeronautical is very excited to introduce the XQ-67A Offboard Sensing Station, OBSS, to the world for the first time. We think you're looking at the future of unmanned combat air vehicles. See Mark Brinkley, a General Atomics spokesman. There is a lot of talk about UCAVs, unmanned combat air vehicles, and what the future might hold. But as people learn more about the XQ-67A OBSS and how the Air Force Research Laboratory and General Atomics have approached this project, they'll discover it really is unlike anything they've seen so far. Specifically, XQ-67A is an AFRL, U.S. Air Force Research Laboratory, program, and GAASI was selected to design, build, and fly that new aircraft. Brinkley added, "Without getting into specifics, I can say that we are stepping through that program methodically and working closely with our government partners to hit all of the markers for the project and deliver on our promises. We're focused on speed to ramp, accelerated design processes, and bringing true capability to the fight." Images of the current XQ-67A, which bears General Atomics and AFRL markings, show that it has retractable tricycle landing gear, a flared V-tail, and low-swept main wings, if any. It also has a top-mounted dorsal engine intake and a recessed chin line that wraps around the fuselage. The design is generally similar in basic configuration to General Atomics Avenger, as well as Boeing's MQ-25 Stingray tanker and Kratos' XQ-58 Valkyrie. The XQ-67A has a pair of air data probes fitted to the nose and high-visibility orange markings on its wings and tail, which are all indicative of an aircraft bound for flight testing. The XQ-67A's overall markings are very similar to those applied to the Air Force's XQ-58 as well as those now operated by the U.S. Marine Corps. Even after more than 2 years, details about the OBS program itself are still very limited. From available information, the past has explored how this appears to relate to efforts to expand the sensor range of manned fighter aircraft, with at least one possible focus being on the role of air-to-air and infrared search and track IRST system. General Atomics has for years been demonstrating capabilities using its stealthy Avenger drones that could be relevant to OBSS. Avengers have regularly flown with potted IRST sensors and worked together with other real and simulated platforms during complex testing events. Some of these tests have been tied to autonomy and artificial-enabled drone operations for air-to-air combat scenarios. IRSTs are immune to radio frequency jamming and can spot stealthy targets that radars may not be able to see. This is becoming especially critical as stealthy crewed and uncrewed aircraft, as well as cruise missiles, are now proliferating around the globe. IRSTs also offer a complementary capability to radars and can scan for threats passively, without emitting any electromagnetic radiation. This reduces the risk that an enemy will be alerted to the fact that they've been spotted or even searched for at all. Such systems on multiple OBS drones that are networked together and operating forward could quickly triangulate the location of potential threats and send that information to fighter aircraft, air defense systems, or even other drones to prosecute. OBS drones could feature other sensors too, such as modular radars and electronic surveillance measure suites. It could also be tied into, or at least help further evolve, plans for groups of uncrewed combat aircraft with high degrees of autonomy to work cooperatively with each other and crewed platforms. These drones could act as distributed sensor and electronic warfare nodes, communications relays, and potentially execute kinetic attacks with the approval of human operators. This brings us to Gambit. As noted, General Atomics has not formally said the XQ-67A OBS design and its new Gambit family of modular air combat drones are connected, but there are some indications that there may be significant links between the two. The company included a rendering of a Gambit drone, a type also known as Gambit 2, in its press release about proceeding to the construction and flight testing phase of the OBS program last year. Gambit 2 also shows a stealthy-looking chine fuselage, a pair of main wings with low sweep, and a V-tail, all of which align with the XQ-67A. This Gambit variant has been shown with a distinctly different two-part blended air intake, with a contoured upper nose section that flows into it. Both appear to have a shuttle-like nose arrangement. General Atomics first unveiled the Gambit concept, which it has also described as a family of autonomous collaborative platforms, ACPs, in 2022. More broadly, General Atomics has long discussed our Gambit series concept for a family of autonomous collaborative aircraft. The Gambit series centers on the same core containing the chassis, landing gear, and other systems. These Gambit cores can be built in large quantities to provide value at scale. Brinkley, the General Atomics spokesman, said in addition to news about the XQ-67A, then the core system can be transformed into various final aircraft forms. Maybe they will be a sensing UCAV or a training UCAV or a shooting UCAV. Maybe they will be a combination of all of those. But unique design is the key to achieving mass affordability at scale and the future of air dominance. And we're very excited about this. Another Gambit type, Gambit 1, has been described as being configured for long-endurance sensing missions and able to accompany manned or other unmanned aircraft to scout the areas ahead of a mission package or patrol for long ranges. It is not intended to carry weapons, and its design with high-aspect wings is meant to allow the drone to serve as a surveillance and targeting node for long periods of time. This sounds a lot like OBSS. An earlier graphic showing 4 members of the Gambit family and its common core shows a near-identical design to what we are now seeing in OBSS. Nearly every feature, minus the edge-aligned upper intake extension, is identical. There have also been indications in the past that OBSS helped enable the California-based company to begin validating this novel concept through the construction of the XQ-67A. The Gambit concept is also aimed at reducing the cost of production, while offering the opportunity to swiftly ramp up manufacturing of specific models as required. On paper, it is a unique, intriguing, and ambitious approach that could be an efficient solution to multiple future air combat needs. This includes the Air Force's budding Collaborative Combat Aircraft (CCA) program. General Atomics is on contract to support the CTA effort, as is Boeing, Lockheed Martin, Northrop Grumman, and Anduril. The U.S. Navy and Marine Corps are also actively collaborating with the Air Force on CTA, including when it comes to the development of shared control architectures and concepts of operations and other relevant technologies. The Air Force is known to be working on an array of other advanced uncrewed aircraft and supporting technologies, including artificial intelligence-driven autonomous capabilities. The rest of the U.S. military is heavily invested in these same general areas as well. Returning to the newly disclosed XQ-67A, the design also illustrates how General Atomics is developing new uncrewed aircraft production lines, following on from its very popular but aging MQ-9 Reaper and MQ-1 Sea Gray Eagle designs. These newer initiatives also include various smaller drones that can be launched, and in some cases recovered, in mid-air, which are often referred to as air-launched effects, ALO. These systems could vastly expand the sensing reach of their launching platform, and could provide electronic warfare and even kinetic attacks over a broader area. In doing so, they could potentially drastically enhance the survivability of the aircraft they were launched from and others in its vicinity. The XQ-67A OBS is another milestone achievement for our team, and we're very proud of it, and so grateful to AFRL for the opportunity to partner on this project. General Atomics spokesman C. Mark Brinkley concluded, "It's a very exciting time. We're looking forward to getting into the deep details about the airplane very soon. While we don't know for certain if we are also seeing our first glimpse of Gambit in the form of the OBS aircraft, what we do know is that General Atomics has built a flight-ready XQ-67A, and it is likely to soon be engaged in an important test schedule that will take the shadowy OBSS program to the next stage of realization."